On the 2nd of June, the World Meteorological Organization stood up in Geneva and told the entire planet to start preparing. Days later, NOAA made it official. El Niño has developed in the tropical Pacific, and forecasters issued an El Niño Advisory. The warm phase of the Pacific's master climate cycle is no longer a forecast. It is here. And here is the detail that should stop you. Underneath the surface of the equatorial Pacific, the ocean is holding an amount of trapped heat that forecasters say rivals the strongest El Niño ever measured, the record event of 1997 and 1998. The engine that drives weather for half the world has more fuel loaded into it right now than it has had in almost 30 years. The agencies are not arguing about whether this is happening. The WOMO puts the likelihood at 80% for June through August, and near or above 90% that it lasts at least into November. The United Nations Secretary General did not soften it. He said El Niño conditions will pour fuel on the fire of a warming world. But the part almost no one is talking about is not the storms or the heat records, even though those are coming. It is something quieter, and the title of this video names it directly. There is one consequence the world is genuinely not prepared for. It does not arrive as a flood or a hurricane. It arrives as fever, in places that have never seen it, while the food the world depends on fails in several places at once. So the question this video follows is simple. If the data this strong is already on the table, why is the most dangerous effect of this El Niño the one with the least preparation behind it? And what is the warning sign that tells us it has begun? If you care about weather, food, and what's actually coming this winter, subscribe and tell me in the comments where you're watching from. Now let's get into it. Part 1, what just happened. Start with the word that matters, advisory. NOAA's Climate Prediction Center runs a simple ladder of alerts. A watch means conditions are favourable for El Niño to form within 6 months. An advisory, the step above it, means El Niño is no longer coming. It is present, observed in the ocean, and confirmed in the atmosphere above it. That is the word NOAA used this month. To declare it, forecasters wait for one specific thing. Sea surface temperatures in the central and eastern equatorial Pacific have to run at least half a degree Celsius above average, about 9/10 of a degree Fahrenheit, for several months in a row. That threshold sounds small. Half a degree across a patch of ocean does not sound like a planetary event. But the Pacific is the largest body of water on Earth, and that half a degree is spread across a stretch of it wider than the United States. The total heat involved is enormous. That is why a number that small can reorganize weather on 4 continents. The international picture lines up with the American one, which is what gives this confidence its weight. The UMO's update put the odds at around 80% that El Niño conditions establish themselves between June and August, climbing toward 90% and higher through the rest of the year. When the US agency and the United Nations agency, using different models and different teams, land on the same answer, the answer is solid. Here is what to hold on to from this first part. This is not a maybe. The forecast stage is over. The agencies have moved from predicting a thing to managing a thing that exists. The WMO's Secretary General framed it plainly. The world needs to prepare for a potentially strong El Niño that will worsen drought, heavy rainfall, and the risk of heat waves on land and in the ocean. Which raises the next question. If half a degree of ocean warming can do all of that, what exactly is the machine that turns a warm patch of water into a global event? Part 2, the oceanic engine. To understand the threat, you have to understand the normal state first, because El Niño is defined entirely by breaking it. Under ordinary conditions, steady winds called the trade winds blow across the tropical Pacific from east to west, from the Americas toward Asia and Australia. They drag the warm surface water of the ocean with them, piling it up on the western side near Indonesia. As that warm water is pushed away from South America, something has to replace it. And what rises up from below is cold water from the deep ocean. That cold water is rich with nutrients, and it feeds an entire food web off the coast of Peru and Chile. This rising of deep water has a name, upwelling. Remember it, because later in this video it is going to fail, and the failure is going to kill things. During El Niño, the trade winds weaken, and sometimes they reverse. The wall of warm water that was being held against Asia is no longer being held. It slides back east, sloshing across the Pacific toward the Americas, and it spreads out along the surface. That redistribution of ocean heat physically changes the atmosphere sitting on top of it, and it pushes the Pacific jet stream, the high river of fast wind that steers storms, hundreds of miles to the south of where it normally sits. Move the jet stream, and you move the weather. Storms that would have tracked one way now track another. Rain that fell on one region now falls on a different one. A continent that expected its wet season gets a dry one. This is the mechanism behind every El Niño headline you will ever read: warm water in one ocean, a shifted wind river, and rain and drought rearranged on the far side of the planet. There is one more piece, and it is the piece that makes 2026 different from a textbook example. A warmer ocean does not just shift moisture around, it adds heat and moisture to the whole climate system, which can worsen the extremes on both ends, hotter heat waves and heavier rainfall. The engine this year is not running on a normal ocean, it is running on the warmest baseline in the instrumental record, so the same machine, fed more fuel, produces a stronger result. That sets up the strangest fact in this entire story, the one that the agencies themselves are wrestling with right now. Part 3, the abnormal signal. Here is where this El Niño stops being ordinary and becomes genuinely unusual, and it is the detail the early coverage mostly missed. Below the surface of the equatorial Pacific, in a layer of ocean you cannot see from a satellite photo, there is a reservoir of stored heat. Forecasters say that subsurface heat right now rivals the record El Niño of 1997 and 1998, which is the strongest event ever measured, and several models are pointing toward a possible record-strength oceanic event later this year. By the raw ocean numbers, this could be one for the books. But the raw numbers have a problem, and NOAA has spent this year openly fixing it. The world's oceans have warmed across the board over recent decades. Every basin is hotter than it used to be. That creates a measuring trap. If you compare today's tropical Pacific to a decades-old average, part of what you measure as El Niño is really just the global warming that has lifted the whole ocean. The signal and the background blur together. So NOAA introduced a new yardstick called the Relative Oceanic Nino Index. The idea is to subtract out the general warming of the tropics and measure only the part of the heat that is genuinely El Niño, genuinely a departure from the new normal. And under that relative index, the same event that looks record-breaking in absolute terms looks more modest in its actual climate impact, with some analysis suggesting La Niña could return the following year. Sit with what that means, because it is the central tension of this forecast. We may be looking at an ocean carrying near-record heat, while the atmospheric response, the storms, the droughts, the rainfall shifts, behaves more like a moderate to strong event than a monster. Record fuel, but possibly not a record-sized fire. That is exactly why the WMO, even with 80 and 90% confidence that the event is happening, still says real uncertainty remains about its peak strength, with most models landing on at least moderate and possibly strong. The honest version of this forecast is not the biggest ever. It is a confirmed event sitting on a dangerously hot ocean, where the gap between how much heat is stored and how much the atmosphere actually unleashes is the thing forecasters are watching most closely. Hold that gap in your mind. It is going to matter when we talk about who gets hit and how hard, and it explains why the official language this season is so carefully chosen. Part 4, reading the official language. When an agency releases an El Niño forecast, it uses words that sound interchangeable to most people but are not. If you can read them, you can read the threat directly instead of waiting for someone to interpret it for you. Start with the alert ladder we touched earlier. A watch is a heads up, conditions favour development within 6 months. An advisory means it has arrived. There is no drama in the words, which is the point. The agencies strip the emotion out so the category carries the information. Right now, we are at advisory. The thing exists. Then there is the strength scale. and this is where the internet language and the official language part ways. You will see the phrase Super El Niño all over the place. NOAA does not really talk that way. NOAA grades strength by how far above average the key patch of ocean runs. Weak, moderate, strong, and at the top, very strong. A very strong event is when temperatures in that monitored region exceed 2 degrees Celsius above average, and NOAA currently puts the chance of crossing that line at around 63%. So the honest framing is not that a Super El Niño is guaranteed. It is better than even odds of reaching the top category, with real chances of landing one rung below. Why does the precise word matter so much? Because El Niño's strength roughly scales with its consequences. A weak event nudges the weather. A strong one is what makes officials warn about worsened drought, heavier rainfall, and elevated heatwave risk across the globe. The difference between moderate and very strong is the difference between a difficult season and a dangerous one, and that is the difference those careful words are trying to communicate. One more piece of official language to decode now, because it controls the entire timeline. El Niño usually begins developing between March and June, but it reaches peak intensity between November and February, and its effect on global temperature is typically strongest in the second year after it develops. That single fact is the most misunderstood thing about this event, which is exactly where we go next. Part 5, the timeline. If you take one practical thing from this video, take this. The El Niño that was declared this month is not at its most dangerous this month. It is tempting to assume that because the advisory landed in June, June is when the impacts hit. The opposite is closer to the truth. In summer, El Niño tends to suppress Atlantic hurricane formation because it generates strong upper-level winds that tear the tops off developing storms. That is a rare piece of good news buried in the pattern, and it is happening now, quietly, in the background of this season. The teeth come later. The event builds through the second half of the year and peaks in the heart of Northern Hemisphere winter, November through February. In a typical El Niño winter, the jet stream drops south and steers storms into California and Arizona, while the southern and eastern United States tend to run wetter and cooler, and the northern states and Great Lakes trend drier. The flooding risk, the storm track, the rearranged rainfall, those are winter stories, and we are watching their setup. There is a second clock running underneath the first one, and it is the one that catches governments off guard. El Niño's largest pull on global temperature usually arrives in the second calendar year after it forms. The strong El Niño of 2023 and 2024 is the proof. That event added a burst of warming on top of the long-term trend and helped push 2024 to the hottest year ever recorded. The heat record did not land while the event was forming, it landed on the lag. So the calendar for this one reads like this. Summer 2026. Declared, present, suppressing Atlantic storms, building, late 2026 into early 2027, peak ocean strength, shifted storm tracks, the winter impacts. And through 2027, the temperature echo, the second-year warming that historically does the most damage to global averages and to the systems that depend on stable seasons. That lag is the reason the most dangerous consequence of this El Niño is also the least prepared for. The threat does not announce itself with a single bad day. It builds slowly in the seam between this year and next, in places watching the wrong calendar. And the clearest example of that slow-building threat is not in the sky at all. Part 6, the consequence nobody is staffed for. Here is the consequence the title promised, the one with the least preparation behind it. It is not a storm. It is disease, and it moves uphill. The mechanism is almost simple enough to feel unfair. Mosquitoes are temperature-bound creatures. The species that carry malaria, dengue, and Zika need warmth to survive and to complete the life cycle of the parasite inside them, and historically. Communities living at higher altitudes were protected simply because the air up there was too cold for those mosquitoes to live. The cold was the wall. For generations it held. El Niño lowers the wall. As the Pacific releases its stored heat, regional temperatures climb, including in those higher elevation zones, and the mosquitoes move upward into newly survivable territory. The people who live in those highlands have never been regularly exposed to these diseases, which means they carry little natural immunity, and that is the recipe for fast, severe outbreaks. A population with no prior exposure meeting a pathogen with a new delivery route is how an ordinary illness becomes a wave. This is not a fringe theory dressed up as one. It is in the official warnings. When the WMO launched its El Niño bulletin this month, it listed the expected human costs directly. More heat-related illness, wider spread of vector-borne diseases, and rising pressure on food and water systems, pushing communities that were already struggling further past their limits. The agency that just told the world to prepare named disease spread by name. So why call this the consequence nobody is prepared for when the WMO is openly flagging it? Because flagging is not the same as staffing. A flood warning triggers visible action, sandbags, evacuations, closed roads. A slow rise in disease risk in remote highland towns, arriving on a lag, competing for attention with the dramatic weather, does not trigger the same response. The clinics in those towns were not built for malaria. The supply chains for the right medicines do not reach them quickly. The early warning, in those places, is a fever in a child who has never had one, in a town that has never needed to watch for it. That is the asymmetry at the centre of this story. The most photogenic effects of El Niño get the planning, the deadliest may get the least. And the disease front is only one half of the human cost, because the same shifted rainfall that warms the highlands is doing something to the world's food at the same time. Part 7 food systems hit at once. The second half of the underprepared consequence is what happens to food, and the danger is not that one harvest fails. The danger is that several fail together. Global food security quietly depends on a kind of staggering. Different continents grow their staple crops in different seasons, so when one region has a bad year, others are usually fine, and the world's pantry stays balanced. El Niño attacks that balance directly because it does not hit one region. It rearranges rain across many at once. The pattern is consistent enough that researchers can sketch it. Even in the current forecast, regional outlooks already point to trouble. The northern Greater Horn of Africa and South Asia are bracing for below normal rainfall during their critical wet seasons, while Central America expects drier and warmer conditions. More broadly, El Niño tends to push drought toward Australia, India and Central Africa, while loading heavier rain onto southern South America and eastern Africa. Now layer those onto a world map of where food is grown. Drought across South and Southeast Asia threatens rice, the staple for billions. Drought across parts of Africa threatens the grain that local populations depend on most directly. And on the other side of the swing, too much rain is not a gift either. Excessive moisture breeds fungal disease in wheat and rots crops in the field. Studies have linked this specific climate cycle to widespread simultaneous crop failures across multiple staple crops, the kind of synchronized hit that strains global supply and drives commodity prices up. This is the part that connects back to the disease story and to the timeline. The WMO put food and water pressure on the same list as heat illness and disease spread, and warned it falls hardest on communities already struggling. A family in a highland town facing a new disease may also be facing a failed harvest and a higher price for what little food remains. The hazards do not arrive separately and politely. They stack. And here is the honest caveat that keeps this from becoming a doom monologue. The WMO was explicit that El Niño does not have to be a recipe for disaster, that advanced forecasts and early warnings exist precisely so this can be prepared for. The collapse is not written. The window to act is the gap between now and the winter peak. Which makes the next question the practical one. Where specifically does the path of this event run? Part 8, the corridors. Every El Niño has a geography. The reason forecasters can warn months ahead is that the pattern, while never identical twice, tends to draw its lines in familiar places. Here is where the path of this one runs, based on what the agencies are already saying, and a clear note on where the lines are firm and where they can still move. Start with the places bracing for too little water. The northern Greater Horn of Africa and South Asia are preparing for below normal rainfall during the wet seasons they cannot afford to lose, and Central America is expecting a drier, warmer stretch. Add to that the classic El Niño drought signature across Australia, India, and Central Africa. These are not abstract dots on a map. They are the bread baskets in the wet season-dependent regions where a missed rainy season is a missed harvest. Now the other side of the swing, the places bracing for too much. El Niño tends to drive heavier rains into southern South America and eastern Africa, and in the United States winter, it steers storms into California and Arizona while running the southern and eastern states wetter and cooler. For the American Southwest, that can mean genuinely needed rain. It can also mean flooding, because the same storm track that ends a drought can overwhelm ground that has forgotten how to absorb water. There is a temperature corridor too, separate from the rainfall map and broader than it. The UMO's seasonal outlook points to above normal land temperatures almost everywhere for the months ahead, with an especially strong signal over southern North America, Central America, the Caribbean, Europe, and Northern Africa. The agency's blunt summary was that nearly everywhere can expect above average temperatures for June through August. That broad heat is the layer underneath the disease and crop stories from the last two parts. Now the honesty this niche requires. These corridors are tendencies, not guarantees. The agencies themselves stress that El Niño's fingerprints vary by region and from one event to the next. A region in the drought column in a typical event can dodge it in an atypical one, and remember the relative index problem from part 3, the real chance that this event's atmospheric punch lands softer than its ocean heat suggests. So treat these as the zones to watch, not sentences already passed. The map tells you where to point your attention. It does not tell you exactly what lands. That covers where the threat goes on land. But the first place El Niño's damage shows up is not on land at all. It is in the water off South America, where that rising cold current we met in part 2 is about to stop. Part 9, the cold water that stops rising. Go back to that rising cold current from part 2, the upwelling off the coast of Peru and Chile. This is where El Niño's damage shows up first and most violently, before a single storm reaches land. In a normal year, the deep water that rises along the South American coast is cold and loaded with nutrients. Those nutrients feed phytoplankton, microscopic plants that form the absolute base of the ocean food web. Everything above them eats because they exist. During El Niño, the warm water sliding east acts like a lid. It sits on top and suppresses the upwelling. The cold, nutrient-rich water stops reaching the surface. The phytoplankton starve, and the starvation climbs the food chain almost immediately, from the tiny plants to the fish that eat them to the birds and mammals that eat the fish. The fish at the centre of this is the Peruvian anchoveta, and it is not a minor species. The United Nations has called it the most heavily exploited fish in the history of the world. It supports the largest single-species fishery on Earth, and it is brutally sensitive to this exact pattern. During the 1997 and 1998 event, anchovy catches off Peru plummeted by around 80%, and exports dropped by roughly 2/3 as the fish died or fled the abnormally warm water. Marine scientists are blunt about the stakes. Strong El Niño years can tip the anchoveta population into outright collapse. That collapse does not stay in the water. The anchoveta is a foundation of Peru's economy and a foundation of its marine ecosystem, and what happens to it ripples outward to seals, seabirds, whales, and to the food security of the poorest coastal communities. A fishery failing is a protein source vanishing and a regional economy buckling in the same season. And the reefs tell the same story on a planetary scale. The 1997 to 1998 El Niño is estimated to have killed about 16% of the world's coral reef systems, as warm water bleached reefs across multiple ocean basins at the same time. That is the marine version of the synchronized failure we saw in the food chapter. Separate basins, the same cause, hit together. So before this El Niño does anything to a city, it is already doing this to the sea. The first casualties are silent and underwater, and they are the early reading on how hard the rest of the event will hit, which is why the next thing to understand is what the last great El Niños actually did when they reached full strength. Part 10, what happened last time. History is the proof here, not the filler. To know what an 80% confident near-record ocean heat El Niño can do, look at the two events still inside living memory. Start with the benchmark. The 1997 to 1998 El Niño formed in May of 1997 and dissipated in June of 1998, and it is regarded as one of the most powerful events in recorded history. Droughts, floods, and disasters around the globe. The damage was not a one-season expense. A 2023 study in the journal Science estimated that the economic losses from that single event reached around $5.7 trillion over the 5 years that followed. That number is the answer to a question people rarely ask. El Niño's bill does not arrive and close in 1 year. It runs for years afterward, through wrecked harvests, damaged infrastructure, and lost income. This is the financial version of the second-year lag from Part 5. That same 1997 event also did something that should sound familiar from this year's forecast. It temporarily warmed global air temperature by about 1.5 degrees Celsius, far more than the quarter-degree bump a typical El Niño produces. A strong El Niño does not just shuffle rain, it briefly turns up the temperature of the entire planet. Now the recent one, the one we just lived through. The strong El Niño of 2023 and 2024 added a burst of warming on top of the long-term trend, and that contribution helped make 2024 the hottest year ever recorded. Notice the timing again. The record did not fall in 2023 when the event formed. It fell in 2024 on the lag. That is the single most important lesson the recent past offers for the year ahead. The heat headline from this El Niño is most likely a 2027 story, not a 2026 one. So what is different this time, and what is the same? The same, a confirmed strong leaning event sitting on a hot Pacific, with the familiar machinery of shifted storm tracks and synchronized stress on food and water. The different, the ocean underneath is at its warmest in the instrumental record, and forecasters now have a sharper tool, that relative index, telling them to watch the gap between stored heat and actual atmospheric punch. The past says the potential is enormous. The present says read the gap before you call the size. Which brings us to a claim that has been circulating about the deeper future, one that needs to be handled very carefully, because it is true as research and false as a current event. Part 11, Fact versus Projection. You may have seen the idea that El Niño is about to become permanently locked into a violent, predictable rhythm, that by around the middle of this century the climate will swing like a metronome between catastrophic drought and catastrophic flood. It is worth explaining clearly because it is real science and because it is being misread as something happening now. It is not. Here is what the research actually says. A 2025 study in the journal Nature Communications, led by scientists at the IBS Center for Climate Physics, used a high-resolution climate model to project that under continued warming, the tropical Pacific could undergo a kind of tipping point, shifting, over roughly the next 30 to 40 years, from today's irregular El Niño and La Niña pattern into a much more regular, stronger oscillation. In that scenario, the cycle would begin to synchronize with other major climate patterns, like the North Atlantic Oscillation and the Indian Ocean Dipole, imprinting its rhythm on them, what the authors call a global climate mode resonance. The named consequence is hydroclimate whiplash, regions like Southern California and the Iberian Peninsula swinging harder between bone-dry and flooded, which makes reservoirs and long-term water planning enormously difficult. Now the part the headlines tend to drop. The study's own framing is conditional. The cycle's response to warming remains genuinely uncertain, with different models projecting a range of outcomes, and the resonance scenario is explicitly described as something that would happen if realized under a high-emission pathway. It is a model result that some other models support and others do not. And related work on whiplash is honest that not all studies concur. So here is the clean line between what is known and what is speculated. The El Niño in front of us this year is observed and confirmed. The locked-in, metronome future is a projection, decades out, dependent on high emissions and openly uncertain. Both can be true. The mistake is to take the dramatic decades-away projection and bolt it onto this season to make this season sound apocalyptic. This season does not need the borrowed drama. It has enough of its own, and it has the advantage of being real. That distinction between what the ocean is doing now and what a warmer century might do later is exactly the line we have to walk when we ask the obvious question: how much of this is climate change? Part 12, the warmer baseline. It is the question under every extreme weather story now, and El Niño is where the honest answer is clearest, because the honest answer has two parts that point in different directions. First part, El Niño is not caused by climate change. The cycle is a natural oscillation of the Pacific that has been running for thousands of years, long before industrial emissions, and it is not directly created by global warming. Anyone who tells you this El Niño exists because of climate change is overstating it. The trade winds, the warm pool, the shifting jet stream, that machinery is natural. Second part, and this is the one that matters for danger, the warmer baseline changes what the natural machine does. A warmer ocean adds heat and moisture to the climate system, and that extra energy can worsen the extremes an El Niño produces: hotter heat waves, heavier rainfall. The framing experts' use is that this event is striking a hotter planet, already carrying brittle food systems and stressed resources, so the same pattern lands harder than it would have decades ago. The cleanest way to say it that still survives scrutiny: climate change did not light this fire, but it soaked the ground in fuel before the fire arrived. This is why the careful separation from the last part matters so much. There are 4 different things people blur together, and keeping them apart is what makes a claim trustworthy. There is the immediate forecast: El Niño is here, peaking next winter. There is the physical setup, a natural cycle on a record warm ocean. There is the long-term trend, a warming world that amplifies impacts. And there is the limit of attribution, the honest fact that we cannot pin any single storm or drought on warming with certainty, even when the broader pattern is clear. Hold those 4 apart, and you can say something strong and true at the same time. This is a natural event, made more dangerous by a human-warmed baseline, whose worst single effects we still cannot predict storm by storm. That is the honest middle, and in this niche the honest middle is almost always stronger than the overclaim, because it is the version that survives contact with the experts. And that amplified, harder landing event does not just hit weather maps, it hits systems, the ones that keep modern life running. Part 13, the systems behind the headlines. The reason agencies are using a word like preparedness instead of just forecast is that El Niño does not stop at the weather report. Its footprint travels into the systems that societies depend on, and those systems are already stretched. The Homo put it directly: the footprint of an El Niño reaches far beyond the Pacific, into agriculture, energy supplies, trade, water resources, supply chains, and livelihoods across whole regions. Walk that chain. Drought hits a farming region, so harvests fall, so food prices rise, so the families with the least margin are squeezed hardest. The same families who, from part 6, may also be facing a new disease front. Each link pulls the next. Energy is on that list for a reason most people miss. A hotter season means higher demand for cooling, which strains power grids exactly when heat is most dangerous. Water is on the list because El Niño's whole signature is rearranged rainfall: too little where the reservoirs needed filling, too much where the ground cannot hold it. and finance is on the list because, as the history showed, the bill runs for years. This is where a sober outside assessment becomes useful. The World Economic Forum argued this year that treating El Niño as merely a weather story risks complacency, and that the 2026 outlook should be read as an early warning of a possible systemic shock, one striking a planet already facing fragile public finances, stressed energy markets, and strained food systems, and likely to test institutions already operating close to their limits. The key word in that assessment is systemic. The threat is not any one failure. It is several stress systems being pushed at once, in the same window, so that each one has less slack to absorb the others. But notice what that same assessment also implies, and it is not despair. The fallout can be mitigated if action is taken. A systemic shock is dangerous precisely because it is broad, and it is manageable for the same reason, because there are many points along that chain where preparation actually changes the outcome. Which is why the next thing to be honest about is where the forecast is still genuinely unsure, since that is where preparation has to be flexible. Part 14, where the uncertainty lives. In this kind of forecast, uncertainty is not a weakness to hide, it is information. Knowing exactly where the forecast is unsure tells you what to watch and where not to overcommit. For this El Niño, the uncertainty lives in 3 specific places. The first is peak strength. The agencies are near certain the event is happening, but they are openly unsure how strong it gets, with most models landing on at least moderate and possibly strong. NOAA's odds of reaching the top very strong category sit around 63%, better than even, but a long way from certain. So the difference between a hard season and a dangerous one is still, partly, undecided. The second is the one we have circled back to throughout this video, the gap between ocean heat and atmospheric response. The subsurface heat rivals the record 1997 event, but under the new relative index, the actual climate impact may run more modest, and some analysis even points toward La Niña returning the following year. That is a genuine fork in the road. Record fuel does not guarantee a record fire, and forecasters are watching that gap precisely because it is not yet resolved. The third is timing and the lag. El Niño peaks in winter, and its largest temperature effect typically lands in the second year, so the most consequential impacts are spread across a window that runs from this coming winter into 2027, rather than arriving on a single date. A threat spread across a window is harder to plan for than a threat with a deadline, because there is no single moment to brace for. And underneath all 3 is the oldest uncertainty in this field. Region by region, El Niño never repeats itself exactly. The agencies stress that its fingerprints vary from one event to the next, which is why the corridors from Part 8 are zones to watch, not verdicts already delivered. None of this is a reason to dismiss the event. It is the opposite. The event is certain, its exact shape is not. That combination, high confidence in the threat, real humility about its size and reach, is precisely the situation that rewards preparation over prediction. Which is the last practical thing worth your time before we close. Part 15, what preparedness means. After all of this, the most important sentence in the entire forecast is the one the WUMO chose to include alongside the warning. El Niño does not have to be a recipe for disaster. Advanced forecasts and early warnings exist precisely so that this can be prepared for. The 80 and 90% certainty about the event is not a countdown to something unavoidable. It is lead time. The whole point of declaring this in June, months before the winter peak, is to convert that warning into action while the window is still open. What that means depends on where you are, and the honest version is not dramatic. It is standard, and standard is what works. The agency's core message to those in the path was simple: start preparing now, before the impacts arrive. If you are in a region the corridors flagged for heavy rain or a southward shifted storm track, parts of the American Southwest, southern South America, Eastern Africa, the readiness is the ordinary kind that saves lives. Know your flood risk have more than one way to receive official alerts, never drive into floodwater, and follow local guidance when it comes rather than after. If you are in a drought-flagged region, South Asia, parts of Africa, Australia, Central America, the meaningful preparation is slower and earlier, water planning, and for farmers, the planting and resource decisions that have to be made before a season fails, not during it. And for the underprepared consequence at the heart of this video, the disease front and the food stress. The preparation is mostly institutional, which is exactly why individuals should understand it. Clinics in highland regions stocking and watching for diseases they have not historically seen, and food and aid systems acting on the early regional outlooks instead of waiting for the shortage. This is the work the WOMO's regional climate outlooks are built to support, in the months before the peak. The through line is that none of this requires fear. It requires timing. The danger of El Niño has never been that it arrives without warning. The danger is that the warning arrives and is treated as a weather story instead of a deadline. So the final question is the one we opened with, now that you can actually answer it. What do you watch, and what does this all mean? Part 16, Return to the Doorstep. Go back to where we started. The 2nd of June, Geneva, an agency telling the planet to prepare. NOAA's advisory days later. The warm phase of the Pacific's master cycle, confirmed and present, sitting on the warmest ocean in the instrumental record. At the start of this video that was a headline, now it should read as a map. Here is what is known. El Niño has developed, NOAA has issued its advisory, the DOMO puts the odds at 80% for this summer and near 90% that it holds into late this year. The ocean is carrying near record heat, the event most likely reaches at least moderate and possibly strong, and it will peak in the heart of the coming winter. Those are not predictions anymore. They are the current state of the world. Here is what is still uncertain, and it matters as much as what is known. How strong it gets at its peak. Whether the atmosphere unleashes the full force of that stored ocean heat, or whether the relative index is right that the punch lands softer. And exactly how the impacts spread across the long window from this winter into 2027. Here is what to watch. Concretely, the monthly updates, NOAA and the HUBMO both refresh their reads on the second Thursday of each month, and those releases are where the strength question gets answered as it happens. Watch whether the event crosses into very strong territory this fall. Watch the regional outlooks for South Asia and the Horn of Africa as their wet seasons approach, because that is where the food and disease story is written first. And watch the sea off Peru, because the upwelling collapse is the early instrument that reads how hard the rest of this lands. And here is what it means, the deeper meaning the opening event was pointing at all along. The most dangerous thing about this El Niño was never going to be the most visible thing. The floods and the heat records will get the cameras, but the consequence the world is least ready for moves quietly, on a lag, into highland towns that have never needed to watch for fever, and onto farms that fail in several places at once. The warning has already been issued. The ocean is already warm. The only variable still fully in human hands is whether the months between now and the peak get used. The forecast is the easy part. The preparation is the choice.